Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, January 23rd, 2022, Sunday, morning 3:29, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 23 जनवरी 2022 सुबह के 3:29 रविवार का दिन। This is talk in continuation to previous talks regarding quality works, concrete material and other materials, field engineering, life and engineers. Also contracts, and because we talk of contracts, we have to refer to red, silver and white books. Of course, yellow books if mechanical is required, and designs and constructions, which are very significant integrated part of engineering. Designs and construction, which are like parents and children, and then methods which are involved to carry out contracts, or you can say execution of contracts. Contracts can be construction related or designs and construction related, and then there is chance that disputes may evolve which must be resolved, and all these are required in all organizations, and career is through all these contemplation in title topics, that flight or carrier, or you can say a kind of imaginary plane takes off and born, flies and then lands. That is communication and coordination, which is of course not physical but actual, without which we cannot move. And here are certain documents. As usual, I show to you regarding my contact, email contact. You can note down or see is written it down, and that is Suraj_engineer, SURAJ, Suraj_ENGINER, and of course at yahoo.co.uk. It's your choice, your option. I would suggest, if you are interested, to contact me, to write to me about this talk or about quality, safety or engineering construction methods. For some information or some advice, you can write or you can comment on comment area on this Facebook or LinkedIn, or you can say, if you are there available on Twitter, you are most welcome to write. I will be pleased. And of course, this is my titles, professional titles: Chartered Engineer India and International Professional Engineer India, International Professional both. And here are, you can certification of International Professional Engineer India, validity 30th September 2025, and every 5 years this is required to be renewed. And this is charter fellow membership certificate, means linked to charter. And here is chartered engineer, that depends on fellow or member or associate member, as I have explained many times. And here is quality file, and I like to close FIE file for current session and C file, and I like to open concrete file, which is in fact very significant. Concrete, ECI and ECI concrete, that is most important. We have covered all this file, but covering is not important. We have to understand, you can say, seriousness of this file, how serious it is for us, and what can we get from this. That's what we have to see. It is concrete terminology. And of course we have another file that we will like to discuss. Of course we continued that yesterday, and that is about I can say durability of concrete. which is just a file from some source. I cannot say that's only file, but reference file it is. Delivery of concrete. There are so many files in future also. I like to get these files through whatever way myself write, or I write myself, or I get reference from internet, and it's really very important. So we have here these files. We can refer to this from time to time. Now I start with my file that is meant for you, and that is quality file. You can consider name of file is quality itself. I have written here. You can see on this screen quality PDF. Here it is, and title is in explanatory mode. Long title it is, and it is active quality performing application. Active quality performing application plus SHE. S stands for safety, H stands for health, E stands for environment, plus engineering approach on designs. Engineering approach on designs and manufacturing as well as construction. A kind of redefinition, though it's not in fact original redefinition, but referral. Means what did we understand before, and what do we understand now, and what should we understand in future for working considerations. It's not something new I am going to discuss with you, but I am going to share with you my views. You can say maybe my views are not good for you. You may know much better than what I know. That is interesting. If you know much better than I like to learn from you, in that case through your comments or through your criticism or through your support, whatever it could be. Everybody has a chance. It is engineering, it's a technical, it's a work, and it's work that works permanently. See, there's a question here, and there's an answer itself here. It's what that works permanently. Construction engineering, of course I cannot say about manufacturing, because manufacturing of materials, manufacturing of parts, mechanical or machines, they're never permanent. They are permanent only during their lifetime, which may be 5 years, 6 years, 7 years, 3 years, 2 years, whatever it is. But when I say construction and civil engineering world, it's permanent work for permanent use. Permanent use means during your lifetime, your continuation during your children's lifetime, and maybe their children's lifetime. So you can say your lifetime, maybe your grandchildren's lifetime. So it's much permanent, much more permanent than manufacturing area. Manufacturing sector or processing sector. Construction is that kind of engineering. You can say if you consider all these factors, the construction is super engineering, super development, and development is always super. You can't imagine how many old cities are available in the world, how many old structures are available in the world. So that's what I'm saying. Today your house may be new, but after 50 years it may not be new, but it shall work. And that's what I say, super permanent work. And you can say today you may be enjoying some house which was constructed by your grandfather, maybe their grandfather. Likewise, okay, it's old now, it's like a ruined area, but it's still there. Just like you can say earth is there for so many years, we do not know. It has been there. So title is active quality performing application, because whatever we do today, whatever we construct today, that is active. But it should remain active throughout its service life, throughout its existence. Does it remain active? That is what we have to analyze. Nothing can be active all time. Nothing can remain active throughout its life in same intensity with which it starts. That's what I say. It's a kind of engineering stress question, stress and strain question, as we say. Stress is proportional to strain within certain limit of elasticity, but beyond elasticity, it doesn't work in that manner. It comes into plastic stage or double, or you can say non-linear stage. That is engineering principle, original, very original and elementary engineering principle. So that is for material, whatever material we have. And here also in quality, We deal with material actually. How do we get material, or how do we generate material by construction or by manufacturing? And that material must have certain quality, and that material must have that quality for its lifetime. But that is in theoretical world. When we see practical aspect of that, every material keeps on changing its constituents, its composition, its conduct, its behavior, its original strength, its gradually depletion of its strength, deterioration of its sound due to atmosphere, weather, or metamorphic action, due to change in its composition to some extent, due to carbonation, due to sulfate impacts, due to chloride impacts, and whatever we can say. These keep on changing quality properties of materials. And that's why I say active quality performing application. Today, what is active quality? Maybe after 1 month, 2 months, 4 months, 6 months, 8 months, 1 year, 2 years, it may change to some extent. So at that time, continuation of activity doesn't remain same, but it goes on changing. And material loses its property to some extent. Maybe sometime it changes its property depending on its use, its hysteresis loss we call it. It gains, say in 10 years or 15 years, it loses some of its strength. Maybe it gains, means I cannot exactly say, but we consider as an independent material, individual material may lose some of its strength due to repetition of forces or actions on that. That's what I say. Active quality after 10 years, 15 years, 20 years may be a little different than what it was in original mode. When we did it, when we applied it, or when we executed this matter, we ingredient, oh, I'm talking about ingredients. Ingredients means steel ingredient. It can be sand, it can be rock, or whatever else. So we have to consider this point, active quality performing application, and every activity you can say amounts to status of an application. An application is a part of engineering, an active quality performing application, and you apply, you perform hundreds of applications in engineering on same project. Every activity is application, and there may be applications in one application, sub applications you can say. And then we have related SHE itself, which is safety, health and environment, safety of work we do. You can say, I'm not talking of human safety in this case. Human safety is also one important part in that activity, but question is safety of whatever material we produce, whatever structure we produce. Safety in use, safety in living, safety in, so if it is design-wise safe, it should be construction-wise safe also. It should be healthy in its own, so that occupants enjoy health from that healthy structure. And it should create an environment of pleasure, environment of happiness, environment of no stress or limited stress. That's why SHE has variant meaning here. Of course, it applies to human being in working condition. When the work goes on, every human should be safe, every worker should be safe. When you occupy certain area, certain structure, you use it, you should be a happy user. Environment should be friendly, not tension giving. And that's what SHE here involves in active quality performing application with good SHE. And this can be achieved only through engineering approach on designs, what we think at time of designs, what contamination we have got in, and that impacts on all this. Manufacturing it may be, or it may be construction later on. Design is one part, absolute part of engineering. Start engineering, and you can say complete contemplation in engineering that happens in designs. And design is something that mind works analytically from every viewpoint, every procedure in design, and then it leads to how to manufacture it and how to construct it. And in both ways we have various processes, various procedures, various methods for each activity. And that's what we can say. Ultimately we talk of works and for defining working considerations. It's not simply system, I'm saying. System is greater part, it's super part, but system can perform only when works perform. There can be hundreds of work activities in one system or one organization. Organization can function only when works are successful. Otherwise, systems are only for namesake, only for certifications, and not for real delivery of what is expected. We cannot isolate good delivery, quality delivery from system, and cannot say we cannot guarantee this work satisfactorily in quality, but we can guarantee system. That doesn't mean anything. It was an idea before, but I don't accept this, because if system works, then you must have quality product, and if you do not have quality product, this means system failed somewhere. System is defective somewhere. This means your system is not strong enough to control work delivery. That's what I say. Quality in our country, so I'm particularly naming this as for country, but it applies all over world. But because I'm concerned about deterioration situation, you can say defective situation quality in general, with some exceptions of course, I can say work quality cannot be compromised. That is main criteria I have to discuss, rather than system quality or quality system. Works quality cannot be compromised. I'm also interested to share my views in other language, that is Hindi in our country, but because Hindi goes to certain limitations, everybody cannot understand, and engineering study is conducted generally in English language, which is much more clear as far as learning is concerned. It is our language also in addition to Hindi or some other regional languages, but sometimes it happens people feel, well, I'm not talking in Hindi. Now if I talk in Hindi, then I have to talk in other languages also. So communication purpose is solved only by simple English, which I think everybody understands, even if you are not having higher education in English. My English is not that strong. You have to open dictionary and see meanings. It's not Constitution of India English, or it's not, you can say, very difficult English. It's very, very ordinary terminology I am using, and this is already used in engineering world. There's nothing as such you have to open. Very, very common conventional talks and conventional sentences I phrase out. So I don't think it should cause some problem. For example, quality is very simple, what everybody knows, and we can say controls everybody knows. So I think we should be very open, and if you think Hindi is also very important in that, that's not an issue. I think we can sometimes talk in Hindi, sometimes talk in English, and we should consider English is like Hindi, means it's nothing very important here. The question is not language, question is how message must reach you, and that is important. And because we have been educated in English generally in all our major professions, so we should not mind, because this is not Queen's English, or this is not some kind of English which we can't understand. So I think you should accept my plea that you consider language as your own, rather than consider it's English language or it's British language. No, it's not that. And Hindi is also not language that owned by us. So we should not mind on this. Important point is how to achieve quality. That's the important point. How to achieve it, how to do it. And that's why I say quality in Bharat, India, with mark of explanations, it is works quality cannot be compromised. And that is sole title actually, rather than all about titles. Works quality cannot be compromised, and we have to deliberate on this. This is, you can say, very important title. This title can change entire scenario. And if systems have to work functionally, they have to work successfully. These systems, whatever we call quality systems, this can work successfully only when works are done qualitatively, or you can say whatever works we do, It may be in designs or it may be in other activities or project. And ultimately destiny activity, destiny is construction. I'm especially talking of construction and manufacturing. So manufacturing is almost organized world. It's almost automated approximately, or it's done through outsourcing. You cannot say much is left there. It depends on individuality only. But as far as in construction world is concerned, we have a lot of ways to amend it, and there is no limit. So if we take construction of engineering or civil engineering projects, works are very important. Here systems cannot give that level of quality as works can give. In manufacturing, in industrial processes, systems may give something, not personal involvement, but in civil construction, because of course machines work there, materials are important, but human resources, because work is done on site. It's like manufacturing on site, it's like processing on site. It's not factory oriented work. Even precast works are delivered onto site. So we can say major portion of whatever works we do, it's continued to be done, and it continues still, it shall continue on sites only. So we have to consider quality of works significantly much more higher level than what we say in other sectors of manufacturing area. And system of course is respected, it's understood, it's applied, but more attention, additional cover should be given to works quality, which cannot be compromised. So we can say I have no right to compromise with works quality, and if every work is done qualitatively, I can say, I can assume, I can promise that system is successful, shall be successful. Quality system may fail, but works quality must perform. Quality system may fail, this is true. Actually, it fails or not fail, doesn't fail, people fail. You know that. System can never fail on its own. It's operatives that force it or that ignore it, and it may fail. But works quality must perform. You cannot rely on system. You have to rely on your working. My working, your working, practical working. Works quality must perform. So this is something, a systematic criticism of system. Though there is nothing to criticize in that. We have to criticize individuality, but individuals are also part of system. Machines shall work according to its program. Material shall work according to its nature, according to its composition, according to how it should behave. We cannot change it. But individuality can be changed, individuality can be trained, materials can be trained, individuality can be trained, it can be taught further, it can be instructed, it can be examined, and it can be checked, it can be improved. But individuality also is a variant part of system, quality system. Only variant is human resources performance. Each individual has different level of training, has different level of efficiency. So every person has to be brought to a silver lining arrangement, to a level where you cannot be lower, you will be higher. You can perform higher. Higher level of performance has no problem, but minimum requirement is a must. And that is what we can say. Minimum requirement of performance is where quality must perform. That's what it says. Works can be said to be done qualitatively when individuals do understand what individuals have to do. And that individual must know before impacting upon or before jumping onto work or into action what is required to be done. That person knows directly by its own experience or knowledge or knows through somebody else's instructions. That is another way. That is different approach. One must know what is to be done. This is preliminary considerations, we can say. Otherwise, nothing can be achieved. There are so many sayings in Sigma, so many sayings IS 9000, so many defects are acceptable, so many defects are not acceptable, this is acceptable and that is not acceptable. I am not going into that elaborative technology because in construction it's entirely different world. Controls are human. Human have to control itself, and human can control itself only when information is available and commitment and devotion is allowed by individual. Every individual is different. We have to realize this fact. And it is artisan work, it is craft work, it's not academical work. It's much more important than academical degree. Works done by human on sites is much more valuable, much more powerful, much more valuable than what is done in clerical office. Because this work is costly, this work is time consuming, and this work should work for its purpose for which it has been intended to be designed and worked out. That's what I say. It doesn't matter what qualification a worker has gotten. What matters is experience of that worker on that activity, how best one can do it. It's much more valuable than only having certain theoretical knowledge or you can say academical knowledge. This is a part of preliminary consideration and this cannot be discarded. Therein you can say another point comes in, where does quality exist? This is very optional point. Where does quality exist? And its question mark. Who can answer this question? I think everybody has to answer this question, but no one answered this question. That is another problem. We don't want to answer questions. We just want to create problems. And that's where we fail. It is duty of everybody to answer. But do we do that? Do we do that? That's my point. Why not to answer questions? That's another problem. Why do you run away from that? That's my problem. I should not run away from answering question. Where does quality exist? Can I ask myself? Yes, I can ask myself. Who shall answer on my behalf? I shall answer on behalf. Or you have to answer. Answer is could not find, unfortunately. I should not use this word unfortunately, but it is to be used because of people like that. Sometimes we blame others. Sometimes we blame this person, that person, this failure, that failure. But we never blame ourselves. And if we blame ourselves, I think there is no need writing unfortunately. I can say it is written unfortunately is written unfortunately. Answer is my failure. And my failure applies to everybody. It applies to you, it applies to someone else. Did you find or can you find for deliberations? If you find answer, then we can deliberate. There is nothing harmful in deliberations. Because deliberation means you have certain doubts, you have certain slavery in your mind, that slavery has to go. It's a kind of, you can say, liberation. When you deliberate something, you liberate something. Because they're trapped somewhere in your mind, in complexity. That is a solution trapped inside, you can't apply it. So we have to liberate those enlightenment ideas. Did you find or can you find that deliberations? For deliberations. That's what I say. Deliberation means it can be individual deliberation, not necessarily you have to deliberate with somebody else. You have to liberate something. Liberation is destination and liberation for use. You should be sure about what's going to do, and that is liberation of your mental decisions. Red lines to be resolved. When I say red lines, this means certain, you can see just like we do red lines, we say these red lines changes, something can say there may be some defects, there may be some errors which we have to set right. That can be in work, that can be elsewhere, that can be in system, that can be in my mind. All those red points, all those signals which have stopped my work, those must be ambered out to green. Those must be ambered out to green, I say, using amber I'm using and green I'm using, so that I can't stop or I restart. Red lines to be resolved. It is very significant phrase. We have to resolve whatever problems we do have, and that's what is system treatment. System may be redlined based on experience. We have to change it, we have to update it, we have to bring it to line of minimum acceptance. Can we bring working environment to quality? Working environment to quality, can we do it? And if working environment does not have that degree of, you can say, acceptance, that degree of comfort, that degree of enjoying work, when I say environment, this means I should be happy while working. Without whom I should feel happy and not stressed. Today we listen, everybody says, I got stress, I worked so much, I worked so many hours, I am under stress. This is fictitious statement, believe me. If somebody works by mind, by heart, there is no question one can be stressed. Tired is different, you can be tired, you can have fatigue. But if it's stress of mind, it's out of question, because work gives you energy. First you give your energy to work, then work cooks your energy, gives back it to you in very comfortable form. It conditions and reconditions your state of mind. And state of mind is very significant. Screwdriver or screw or motivator or propeller for your further efficiency. So I should not accept this term. Stress, generally I find young people, I'm very stressed, I work so much. This means you do not find interest in work. That's why you are stressed. And work, if it doesn't give you happiness, I think there is something wrong either in that work or in your attitude. You don't like to work, but you are forced to work. Only then you can say, I am stressed. It's like police dealing in third degree treatment with criminal or accused. It's same way. You cannot enjoy your work actions, your work performance, what sort of work you do. Have you seen artists? Artists who drawings, who make some picture. That artist never gets tired. Yes, can be fatigued after continuous working of many hours, thinking of day and night. That artist, when sees picture, he likes it, he enjoys. You see what was in my mind, I did not even know. But it has gone to this level. That's what's called happiness. Same way design should feel happy about, oh, I have got this designed, this is drawing here, this is I given details, and I feel something, I achieved it. But nowadays it's not that state because computer is involved everywhere. So computer has taken your activity and therefore you feel stressed because you have done something, you're not happy that you have done it, computer has done it. Well, I'm not criticizing computer, don't take it otherwise. I also use computer. I'm just trying to explain something. That if you do everything, now example is previously we used to calculate ourselves. Every work, every calculation, every formula. But now it's not required. So we feel withdrawn from that. We feel withdrawn from that active mind, from that fast mind, rapid mind, and now speed of calculation has gone down. And when speed of calculation mentally has gone down, we don't have that caliber. We cannot think that way. We think now synthetically, not analytically. That was the difference between two. Today, nowadays, because of introduction of computer and its intensive use in every activity in our work, we have reduced thinking power, you can say, in a analytical way. We have reduced, and the analysis power has gone down. Only synthetic power has come up. Analysis is inversely proportional to synthesis. Synthesis is what you say, you have to analyze first and then you have to combine those or merge those answers, and that is called synthesis. But when you don't analyze yourself, somebody else works for you, then only that somebody else can synthesize for you. So that is what worrisome. That's what I'm saying. Can we bring working environment to quality requirements? All these actually I'm discussing are quality requirements. Thinking is required behind everyone. Thinking. What is thinking? Analysis is thinking. There may be some wrong activity I have done. I have to think on this. Though it may be referrally wrong, it may not be referrally right. Otherwise, it is right because it is work. But it may not fall in line to what I thought. It may not come in line to my contemplation. So for me, for that situation, it may not be suitable. But it is not unsuitable. That's what I say. At some point, what I say is not qualitative, but it doesn't mean it is rejected. But it's not going to work for that activity, for that moment. So what I say, how to get environment suitably to your work. It's very important point. Without your mental control, work cannot be successful. And work can be successful only when it has got quantified quality and qualified quantity. Qualified or qualified quantity and quantified quality. It can be value added also. It depends. I am not talking of value addition here. Because first you get whatever is required. Equivalent or equal or required. Once you get that quality level, you can further add values to that. And that's very important point. Certain red lines that must be turned green. That's what I am saying. We have red lines. We have to remove those red lines by getting solutions and put that solutions on our drawing so that reliable as-builts are produced and our as-builts in quality system. I am talking. We have certain old, obsolete, we have to update it, and that update is red line solutions. Those can be approached in that old system so that it becomes updated. And that's where point lies in. That point is very important. We have to understand that fact. Certain red lines that must be turned green, and what to do about that? What to do about that? That is point. You can see this file has been very old now. So many dates are indicated on its header, you can see, and that's all amendments made from one point to other point. Why say worsening state of quality of works? That is, you can say, boosting title for this talk. Worsening state of quality of works. Worsening state of quality of works and how to improve such mandated works quality to certain minimum required marks. I think battery fully charged and I can update on this. I put off for some time. My battery to be put off for some time and then less than half an hour after that I restart it. Okay, yes, please. gentlemen, I think. Alright, worsening state of quality of works. What to say about that? Worsening state of quality of works and how to improve such mandated work quality to certain minimum required marks. That is first requirement. Of course it is. Then you can say another one is worsening state of quality of works, of quality of concrete, I'm sorry. First was the quality of works, and then same question lies in and is repeated as worsening state of quality of concrete and how to improve such mandated quality to certain minimum required marks. And then of course it is worsening state of communication and coordination during working on engineering designs and executions or construction activities. Communication and coordination, cover marks you can say below cover mark of this quality talk. Communication and coordination I consider very significant part of working quality. So this is not directly a piece of quality but a supporting system of quality. Communication and coordination, which if successful, it's very helpful, and if it's ignored, it is very defective. It brings to a state where your works is incomplete or is impacted upon by some misinformation or wrong information. And all this demands determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth. Determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth. Now, can we do it? Can we do it? Or we are incompetent, inconsistent societies and communities in engineering. Are we engineering force or incapable lot? Shall we make engineering a quality force? Who shall decide about all such questions that are being faced in current scenario? Now, these certain points amount to a kind of questionnaire, and this questionnaire is reality based. It's not a student's question, these are professional questions. In construction world, lot of controls are required. Quality is not easy to be achieved in construction world. Reason being, first of all, we should know what we have to do. That is main lead. And that is really unclear. Because we always say everybody should know what is to be done. Everyone should know what is to be done. Because one-to-one supervisory management, supervisory work or supervisory standard is impossible. We say, for example, there is one foreman, that foreman or leader has, or lead has to look after 25% or 50%. It depends, but can that person check work of everyone simultaneously? That is an important point. This means quality of works becomes a question all time. No work is independently done by one person. That's also true. If we can understand how to get quality in one activity, we can spread that information, we can disseminate that. Our worker should know. When I say worker, means every worker, from engineer to downwards to every helper, or everyone who is involved in activity physically. That worker should know what is minimum criteria one has to do. It's also not possible that every supervisor should be present at every activity all time because of limitations, and of course no one can perfectly do this. Moving or walking around site is different, but involvement, as you can say, dedicated activity hours wise or minutes wise is not possible. How to control works? Even excavation is also an important item, though we don't care for that. Important is every activity. And there are many kinds of activities, many easy or difficult activities. It's not simple work quality, it's work safety is also a part of quality. Work safety, person safety, environment safety, health safety, standards of item we produce, whatever, how to arrange materials quality, how to manage, how to organize, how to ensure, then how to ensure processing quality, or you can say procedures. All these are important one, and this cannot be done in 1 hour or 1 minute. This is continuous process for all works. Material controls, human resources controls, controls or mechanism of machines, controls of, you can say, technology, or whatever technology we have, we have to try that and work on that. And of course we have to prepare, we have to keep our workforce ready for that. If workforce is not ready, that becomes a problem. That becomes very important problem if workforce is not ready, because if workforce is not ready, we can say we are not ready. It's also a very important point. Workforce should be ready. And every engineer is also a part of workforce. That facts cannot be denied. If we can train engineers in addition to their whatever knowledge they have in university during their education, other knowledge is important. They have already knowledge. They have many subjects, they know about that. For that they can review, go through books. But knowledge that they have to acquire on practical site, that cannot be achieved from books. They have to work on sites. Only requirement, only answer is they have to work on sites under already experienced engineers who know quality and not non-quality engineers. And we can say it's only work, it's only attitude to learn, it's only attitude to criticize, it's only attitude to think why it's done. Work should not stop. I do not say to stop work, but why I'm working this? Everybody should raise question if you are a qualified person. And if it is necessary, you can explain to your workers why we are doing this, why not your way. Maybe sometimes workers' way is better than your way. Then you can chart out, okay, your idea is very excellent. I respect your idea. Your idea is very good, but there is some additional requirement in this from project viewpoint, and that is this one. Therefore, your idea is to be amended, including this proposition. That can also be done. It's not theoretical, and it's not in writing. It cannot be in writing. It has to be interactivated. It has to be conversational. It has to be conventional. Likewise, you have to discuss with your people while doing some activity through foreman. Not necessarily you directly. You have various leads there. Your supervisor, your lead, or gang leaders, or crew, whosoever, who can transmit your views to that level where these are implemented. You can say systemize in one way or other way. Quality of works is that kind of dissemination information, and you have to teach them all time through manufacturer's instructions, because these people cannot understand what is manufacturer's instructions, but when they work, they have to work they have to work according to instructions, and whenever whoever is there, supervisor or trainer or whatever you can say, that person must know first what is manufacturer's instruction for that particular material, which is non, you can say, in list of ordinary activities. Some materials are really technical based, and these materials have to be worked out same manner as manufacturer's statement says. So we have either get those people trained through demonstrations by manufacturer's representative supervision, and that once or twice if it is done, these people can absorb better and they can repeat that provided supervision is conducted. That's what we can say, manufacturer's instructions. And also we can say our own instructions. Whenever we do structural activities, generally all activities that are carried out have got some detailed drawings, and not only detailed drawings, these are having working drawings for preparatory works, working drawings for temporary works, all are there, and then this information must be given to those tradespersons, those artisans or craftspersons who directly are involved with those activities. It's not only that we have to tell them what I'm saying to do it, we have to give them certain sketch so that that person also, we can get that artisan, that skilled person with us to confer with. That person must know what is to be done, and that person must know what accuracy level we expect out of this work. Work we can say, it's workship. I'm not saying workmanship, I'm saying workship. Standard of work you have to achieve. What kind of checks you are going to control with, what you are going to manage, what kind of checks you have to apply, and that's what we call quality control. Every level of quality control is to be worked out, is to be ensured. And that's I say quality of works. Quality of works means quality testing, quality control, quality measurement, quality application, quality consciousness, quality working attitude. All these are interrelated in system. So we have to go into detailed system rather than only quality system. Quality of works, and it's very significant in construction engineering or in civil engineering. In whatever subtitles, in whatever subheadings or whatever other vistas of civil engineering, it can be road work, it's infrastructural work, it can be hydro, you can say hydro related work, it can be irrigation network, it can be hydraulic resources, water resources, it can be, you can say housing, it can be plants or facilities, it can be infrastructure like airport, or you can say powerhouses, or whatever we have. All projects have same kind of problems. We have to understand all this. Quality of works are different, nature of work is different, specifications are different, requirements are different, but original thought is same, quality. Maybe you can say in excavation there is no need of checking all this. You may say that, but remember, excavation is number one activity without which we cannot do our works right. We should know nature of soil, of course it's very important. We should know stratification of that area. And if we do not know that, we just go on blindly. We waste time, of course we waste cost, it happens. So it's also important that we should have determined, calculated and reliable information for every work we do. My question again was how to improve such mandated works quality to certain minimum required marks, and answer is very simple, very clear. I'm not saying you read books or write books, no. Think of what's to be done, how it's to be done. Think sharply, instruct sharply, and if it is required in form of some statement, write that in simple language but clear message should go to that level of worker who has to do it on site, and this should go directly by you or from you or indirectly through your site organization leads. So it says worsening state of quality of works and how to improve such mandated works quality to certain minimum required marks. Means we have to involve ourselves everywhere in every activity. It may be surveying activity, or it may be earth excavation, or excavation in earthwork, you can say. It may be understanding excavation. It may be agreeing fitness of levels of excavation, or what kind of soil is there. Is same as we designed for, or it is different, or it's pile work, or it's spread foundations, or what we have to do. We have to make sure design whatever we are going to follow, of course, is suitable for that, and that ordinary engineer can understand. For this, no specific education is required except your own degree, because you know in that what is soil through construction engineering. You understand nature of soil, you understand what kind of stratification is that, and I am just referring to that. So you can say quality of oxygen applies to excavation. It applies to all items. It applies to each and every item. And then we can say important part of materials that we produce on projects and we use for permanent work production, and that is almost concrete. And concrete is, when you say concrete, it's widest technology nowadays. Even after passing your engineering materials subject, he cannot have full grasp of concrete, because concrete itself is a kind of engineering, I can say. It's not simply subject. We cannot classify subjects these days. It's a domain now, just like we say domain within major domain of civil engineering. There is this design domain, there's construction domain, and likewise planning domain, quality domain, safety domain. There is concrete domain, we can say, though it's not formally domain, but it can be assumed to be domain within the domain. And that's where we should reflect our importance onto that, our significance, that learning concrete is very much requirement. Outstandingly it's required to learn concrete more and more and think less and less about I know something. I know nothing. Of course I know nothing, because when I was a student of engineering at that time, concrete was not that expensive. It was just considered ordinary material. But now concrete has its vistas, its wings spread over. Now at that time I used to say, okay, it's 1:4 mix, or it's 1:4:8 mix, or 1:5:10 mix, certain fixed ratios. And we used to think that's only quality. Just takes a cement equivalent, cement volume equivalent timber box or some box and measure. You aggregate in this proportion, and so water cement ratio. That was primitive one. But now it has gone beyond our learning stage. Practical learning is important. Concrete quality is very important. Concrete is a material now currently, and of course in future it is that manufacture, is that level of working or procedure that concrete is like a domain. It's unclear to every engineer, even those who deal with this. They do not know exactly what they are going to do, because total conduct or total working or total behavior of concrete is still unclear. But unclear or clear, we use this material, we should keep in mind. We can say what is we do, what is to be done, what do we do? Is that right, or it's only a part of acceptance? It's a partly acceptance, you can say, because we may not be clear about future conduct of concrete, say after 20 years, after 30 years, after 40 years. We cannot guaranteedly say something. It's right. How can it behave after 40 years, 50 years? We can know only when we test it. And we test existing structures. We have not done that way. Current technology is related. That technology was very primitive, it's gone. So what say? Whatever we have, it is worsen. It should worsen. It would worsen. And we have to keep in mind that worsening state of quality of concrete. Worsening state of quality of concrete, and how to improve that one, so that at least my concrete is produced and it is allowed to work at least to that required mark, minimum required mark. These two are very important points of quality of works related to every work and quality of concrete related to concrete work. And if I say we engineers, we know it, we realize it, but we are not serious, problem is there. We may work with contracting organization, or we may work with quality organization, we work with government organization, wherever we work, we do not have that level of seriousness in respecting permanent works control stages. And because we do not care for this, sometimes we can bring it to, you can say, into controls. If somewhere we fail in doing our activity through communication and coordination medium. And communication means it can be controlled only, it can be understood only when whatever information we have, either we use it, we understand it, and we spread it to others, to disseminate to our colleagues. Otherwise, communication is missed, or it is partly used. And then if you use this communication for partly only in coordination, then we cannot get complete process. Quality of concrete or quality of works can be affected only if we have full information, or whatever possible information we can have, depending on today's status. Whatever has gone in past, we cannot change it. Whatever is going to happen in future, we do not know exactly. But whatever we have in hands today, it should be fixed one. So we can also say communication and coordination are our also one of destinies, that we have to be smart enough with that. What level of communication engineer does, everybody knows. Verbal communication is preferred than written communication, and we know that people forget. If you instruct someone you have to do this activity, of course first of all that one may not have 100% reception of your instruction, maybe half, and then if that person is directly responsible, or that person has to pass this information to someone else, so you can say effect goes down and down. Communication and coordination have to work together, and coordination is very significant title. It is actually result oriented. It is mix of results, mix of decisions that coordination performs. Coordination says you have to apply this way, that's what is required. We are not to apply other way. And if you can't apply this way, you have to find what problem lies there. Something we have missed or something we have not understood, or material we are going to use, we don't understand what this material is, how it should perform. We just conventionally cook it and eat it, and that's not possible. In real world, it has to be understood properly. We have to understand by experiments, or we have to understand by testing, or whatever way. Communication, coordination can work only when we are active. We remain active, not passive. So I say worsening state of communication and coordination during working on engineering designs and executions or construction activities is also one reason that has supported, that has helped in slump of quality, slump consideration of quality, slump level of quality. We have lost quality, more and more slumped out, or you can say it's flowable. Our solid system has flown, and if solid system is flowable, it's not solid system. Determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth. These are only few requirements that I covered. There are so many other requirements. In one talk we cannot consider, cannot take all that. So what I say, determined and dedicated role of engineers towards realizing these requirements, and else quality remains a myth. If we claim my design is excellent, it's been with so much concentration, but we don't keep in mind that it should not remain on papers or on soft copy, but it should be done, it should be carried out in physical terms. And if it's not done in physical terms, we can say something wrong somewhere. We are not implemented that. This means we have not affected our role as engineers. We have to determine what is to be done. And that determination is not just by reading, but by understanding how can you do it better further, so that it should be value added. But it cannot be taught blindly. You cannot just in certain reference say I have done it. You have to do it. Role of engineer is very, very clear in engineering. Though it's very complicated in element wise, in subject wise, but the role is very clear, very, very clear and ground that we have to function as every activity that we do, or individually I do, that should comply in full with project requirement or with quality requirement. That is a must. How to do that? That is a real question. How to do that? Role of engineers is not easy. It's a responsible role. It's obligatory role. It's legal role, and it fulfills legal requirement. It's not just putting something onto tray. It's not something like that. It is to be thought a lot and then applied gradually if I understand that or if I don't understand that. So we can say dedicated role of engineers towards realizing these requirements, or else quality remains a myth. We do not want quality to remain myth. It should be worth, acceptable worth. Can we do it, or we are incompetent, inconsistent societies and communities and engineering? It's very, we can say, very, very practical query. Can we do it? Well, I think we have to say we have to do it. We have to do it. Otherwise, no meaning at all. We cannot find quality in our works. in our works. And that is where root of problem lies in and root of solution lies in at that point. Every person in engineering is, you can say, responsible. Every person who deals in engineering directly or indirectly is responsible for good quality or bad quality. Can we become a force, united force of engineers? I think we do not know now. Maybe in future we know we can become, but now always there is, you can say, fall and rise in life. A slump is there, which may be redundant, which may be within limits. Redundant is no meaning. In that case, how can we change our engineers' totality into economical strength? Strength that impacts economy. I am not saying current economy, I am saying channel economy. Without economy, functions in life are not possible. Therefore, we make engineering a quality force, and how to make it. Unfortunately, engineers are not that powerful. Despite their job is very powerful, they are not powerful. They can't speak openly. They can't claim that we have to be designated. And this weakness of our leaders has brought our state to this level. Really, it is not happy situation. It's not good situation. We have to think otherwise. That's what I say. These questions are general and repetitive, and we have to then deliberate in details. The dissemination of engineering information about quality requirements and how to transform using method statements. And the general description here is about requirements of method statement. As I said in first point here, methods. Then question is methods, or you can say explanation is, rather I should say, explanation is this way. Explanation is the methods can be designed and drawn. Methods can be designed, or you can say action of line can be defined. Action of line can be defined on methods. Or you can draw it in writing or in sketch way. It's called drawing of method statements or statement writing, or you can use your way, but I can call it methods can be designed and drawn or stated for designs, for execution, for carrying out activities, as well as for rectifications, remedial, and for services. That is what methods can be allowed, designed, drawn, stated, for designs work, for execution work, for carrying out activities, as well as for remedial actions or rectifications, for services. There is one disposable point is very important. And then we can say methods term is this use means comprehensive methods and not selective one. We cannot simply take out something, see given here I am going to do this. You cannot have excuse on this requirement because it is also a totality. Totality is required, not selective. We cannot select something, okay, this is right, therefore previous one and next one shall be right. We cannot say that. We cannot claim by selective action, this is chain activity. No work be carried out without referring to method statements. That is elementary requirement. That is, you can say, mandated requirement rather. No work can be allowed without referring to method statements compliance, which must contain how to handle SHE on that activity, how to have quality approach at every possible and convenient stage. And that's where method statement plays a role, positive, effective, powerful role. How to work on method statements, how to work on procedures, and what about contracts for construction? Because when we either we do ourselves, that's not practically possible because so much actions are required in construction, so many stages are required in manufacturing. So we are inclined to within limits of construction now. Then construction cannot be done automatically. It cannot be done by assumption. Construction is done only by spending hours together, our own hours, our workforce hours, our machine hours. We have to work for certain limited time to deliver that piece of work that we had. It's very important situation, very important point, and this cannot be taken for granted. So what about contracts for construction then? Construction cannot be done without contracts. We cannot do construction without contracts, practically speaking. Theoretically we can do it, but you can do it only when you know everything about that. If you do not know what is right construction, what is wrong construction, and you think whatever you've done is right, it may be right, it may not be right, that's a different one. But your decision power is so strong at a moment that you can decide about your future, you can decide others' future, and that's where we're not going to work. When we say contracts, this means a liability on both parties. When we say contract, what is contract? Though contract law is same, contract requirements are same, contract's minimum considerations are same, but levels of cost, levels of price, and various other conditions impact upon, and that's where we say it's very important point to think like this, to do it like that. But it doesn't happen because of, you can see everybody is tired in morning time. You get relaxed up or you may not get relaxed up. It depends on how strongly you have planned your body. Same way I say we have to think of construction. That whatever keeps you happy, if you see, okay, I am fine, I think that is where problem lies in. Important problem lies in. We have to design, we have to construct. For construction we have to procure. We have to design according to original question. What we have to do? What is the right way? I suppose there is some answer like this, which clearly means very important. Always we say contracts, the construction contract, or you can say engineering, procurement and construction contract. Otherwise you can say these are very important questions in these contracts. We must learn them ourselves, or when you have time. Contract has been missed by many people, and that been missed by many people. We will discuss contracts. Indeed, it's very important part. What is contract? How it's handled? How is Red Book? How is Silver Book? That is EPC, and Red Book means construction contract. And how is White Book? That is consultancy services. And likewise, there are others. The only point here is just to know what we are going to discuss in this red system. Red and blue, red system, and you can say in dia system. Should engineer know it thoroughly? That's what we have to think about. Designs, procurement and construction. Three responsibility are, of course, these are separate one. Design responsibility, you can say one column, then you can say temporary works, second column, and over is all. That is what we have to think of. Now we are going to jump before on other points of view. I like to jump onto these terms later. Now we have to go to durability of concrete in Arabian Gulf, though spelling is wrong, don't worry. It is Arabian Gulf, not Arabian Gulf. I taken this file from internet, so I could not correct it. Next time we'll look into this. If I write wrong, no problem. That's not point here. We conferred yesterday about, in abstract it was just for introduction purpose that it's for Gulf, I discussed at length here. But just for information, I repeat this abstract so that you know what we are going to think of, and remaining part we did last time, long one. And this is about Gulf, that is GCC, Gulf Cooperation Council, Gulf Cooperation Council, and it says Gulf region is witnessing extensive urbanization. It's long back. It's happening still now. Gulf region is witnessing an extensive urbanization. Development and billions of dollars are spent on reinforced concrete construction projects. It's a reinforced concrete construction project itself, RCC project. Estimated that present projects in Gulf states are in the range of $800 billion. So this is just a reference, and by 2020 it's already gone. By 2020, 6 of tallest 10 buildings in world are to be part of this region. These projects not only exert pressure on resources but also require high performance material, top organization, and greater quality controls. These are all, you can say, requirements. All over region there are many concrete structures, and that's no doubt there are hundreds and hundreds of concrete structures in GCC, and of course strong one, and you can say all over region there are many concrete structures which are outstandingly good condition compared to age. But we have also examples of structures that within few years deteriorated to poor condition. It happened. Many buildings as such, many RCC buildings exhibited cracks, signs of distress early in their service life. Awareness of importance of concrete durability has risen in region, along with need to stretch concrete to its uttermost limit. And we can say in many parts of Middle East there are important factors such as unskilled workforce, deleterious substances, funds, and speed of construction that influences durability of structures and bridges to great extent. Considering hot and arid weather in region and need to use high strength concrete brings forward problem of concrete durability. In hot weather, it can be seen that concrete structures tend to deteriorate more rapidly, exhibiting greater problems with cracking control and those in temperate region of world. Maintenance in Middle East has consistently been treated as secondary activity. In construction industry, attracting only a minimum recognition of its importance. In recent years, maintenance has gained greater attention since it's being looked to as a tool towards sustainability and a mean towards conservation of construction stock. Now it's a paper only, it's nothing else. So it's given in this paper a brief summary of research and issues related to durability, hot weather, concreting, sustainability and maintenance. Presented results of an investigation on effect of hot weather or cracks and non-destructive testing elaborated. We have gone through these pages. I will go back to some. Sulfate attacks, carbonation, chloride corrosion we had done. Environmental cracks, and there, I think in 29 it was some here. So we can see what's some here. Let's start from here. He is getting stricter on environment friendly side to development. UAE is getting stricter on environment friendly. UAE is getting stricter on environment friendly side to development. More so because of rapid scale of development in so short a time, just 30 plus years. Development which sometimes has been at cost of environment is every country's, every region's natural heritage. Cost of environment by its talking. Environment is not your build-up. Just like air is not our build-up. You can say air, water, all these are not our build-up. We have to depend on nature to get more and more. But that's what is important for discussion. Means development which sometimes has been at cost of environment and is every country's, every region's natural heritage. That's what it says. A fast growing population in that area, immense financial resources, and an ambitious development program all have combined to place strong pressure on environment in this area, UAE. Combination of all factors, as we said, these factors are very important. That is to enforce existing environment and to control how it can be done. That's where it's an important point. Growing consensus from major industries analysis is that technological innovation, if engineered in an environmentally conscious way, brings back both reduced cost and interacted efficiencies into their operations. Institutions across Middle East are recognizing, they recognize environmental protection laws can actually help to drive positive economic growth. Environmental protection laws can actually help drive positive economic growth. However, practical meaning of sustainability is open to much debate. At minimum, it is a call for steady reduction of air and water pollution. Important is steady reduction of air and water pollution, reduction of and recycling of wastes, more efficient use of energy, and a shift to renewable energy sources, restraint in development of rural land. So many reasons are here, which is a minimum one, and nothing very specific. And that's a call for study. That is how to study the reduction of air and water pollution, how to reduce that, how to reduce air pollution and how to reduce water pollution, and of course reduction of and recycling of waste, more efficient use of energy and shift to renewable energy sources, restraint in development of rural lands, restraint in development of rural land, a dedicated view of sustainability, demands major shift in our lifestyle, towards smaller homes. Just notice that. Sorry. So we say what we have to think of this is very important point, keeping in view so we say how to improve air and water pollution and how to reduce recycling, how to increase how to increase recycling of waste, how to do more efficient use of energy and shift to renewable energy sources, and restraint in development of rural land. Now, a dedicated view of sustainability demands major shift in our lifestyles towards smaller homes. Sustainability demands major shift in our lifestyles towards smaller homes, use of mass transit instead of automobiles, use of mass transit, and that you can say public transit mode, and reorientation of marketing towards frugality rather than consumption. It's the important point. Reorientation of marketing towards frugality rather than consumption. While some of these policy choices are made in local communities and households, large-scale implementation depends on choices by national government and major corporations that compete in global market. Something very important we have to be clear about here, certain terminology that we use, and that is frugal. What is frugality? We can say frugality is quality of being frugal, sparing, thrifty, prudent, not clear. You can say kifayat shari. And frugal definition is meaning of frugality is quality or state of being frugal, careful management of materials, resources, and especially money. Meaning of frugality in English, quality of being careful when using money, food. So, frugality is quality of being frugal, sparing, thrifty, prudent, or economical That is what it says, frugality. And we can say kifayat shari in our language. So leave it now. I'm not going to explain it lot on this. That's what I say about frugality. Means we have to use it properly in a way that it works very well. And works very well means it has to be in that state that we think it should be. That's where frugality works. So we can say here that, sorry. So a dedicated view of sustainability demands major shift in our lifestyles towards smaller homes, use of mass transit instead of automobiles, and reorientation of marketing towards frugality, economical use of money, economical use of material, economical use of every requirement rather than consumption. While some of these policy choices are made in local communities and households, large-scale implementation depends on choices by policymakers or by national governments or state governments and major corporations that compete in global market. Even then, planners recognize that even small-scale choices have incremental effects on their environments, and there is growing interest in alternatives that promote sustainability while not violating freedom to choose our lifestyle. Therefore, we should aim to achieve a balance between environmental protection, social progress, and economic growth. What we have to do? We have to have an objective to achieve a balance or an equilibrium condition or state of equilibrium among environmental protection, social progress, among environmental protection, social progress, and economic growth while working in harmony with Earth's ecosystem. Hence, sustainable development means what it says is reduction of emissions. That's of course right. Reduction of emissions, more efficient use of resources, better reuse of waste, increased consideration for people's health and safety. These are very normal. Emissions control and resources best use, waste recycling, and of course health, safety, and I can add on top of all these quality issue. Quality issue. Fueling environmental building revolution are new materials. Environmental building, or we call buildings fit for natural use, to be very frank, not artificial orientation. And topmost among them is glass. We say chief among them is glass, stronger, safer, and more energy efficient than ever. Low emission glass lets visible light in. You can take sunlight through glass. So low emission glass lets visible light in but keeps heat out. That enables architects to add windows and light without having to double up on expensive air conditioning. Smart wrap is a transparent building membrane that adjusts its properties to change in light and temperature to keep building climate controlled and well lighted. This is a statement made by these people, and you can see yourself also what it says. Very simple. Fueling environmental building evolution means you have to propel environmental orientation for new buildings, and you have to use new materials and considerable parts in that is glass, which is stronger, safer, more energy oriented, more energy efficient than ever before. And it should be low emissive glass, which lets visible light in, allow light to come in your covered area, and keeps heat out because of your tint on glass. It's not 100% allowing sunlight to go in, but light goes in without temperature. Temperature remains outside, in particular to 70%, may probably it remains outside. And this situation enables designers to add windows and light without having to double up on expensive air conditioning. Percentage is how much in this thing? So I have to go back and see. Well, no problem. So it enables our designers to add windows and lights without having to double up on expensive air conditioning. And Smart Wrap is a transparent building membrane. And Smart Wrap is a transparent building membrane that adjusts its properties to changes in light and temperature to keep buildings climate controlled, well lit. You can say well lit rather than lighted, well lit. Now here's Dubai is let's give the example of Dubai, a city in UAE. Dubai is home to one of region's first green shopping malls. And an eco-friendly mosque was built in 2013. Many other examples can be found in Abu Dhabi, capital of UAE, Masdar Institute, world's first graduate level university dedicated to providing real-world solutions to issues of sustainability. Institute's goal is to become a world-class research-driven graduate level university. And that is a Masdar Institute. Institute goal is to become a world-class research-driven graduate level university focusing on advanced energy and sustainable technologies. Masdar city promises to be a model for green cities all over the world. Now Qatar's goal to reach leaders of sustainability in world was started in 2010 on Mashrab downtown Doha, which promises to be world's largest sustainable community with 100 buildings using an average of a third less energy. Another project is Lusail City, a planned development for nearly 200,000 people on edge of Doha, has promised to adhere to countries' voluntary green buildings guidelines similar to those in UAE and other Gulf countries, which set standards for everything from water consumption to traffic congestion. If green building technologies were used in Middle East, instead of usual technologies, environmental problems will be tackled. Just a minute, please. If green building technologies were used in Middle East instead of usual technologies, environmental problems will be tackled significantly in addition to long-term financial returns. In terms of overall sustainability, MENA region shall still late compared to other markets, but in next couple of years Certain percentages of companies in this region have over 2 million square feet of green projects. All right, anyway, construction durability issue is continuing. Until 19th century, buildings of over 6 stories were rare. Until 19th century, buildings of over 6 stories were rare. It was impractical to have people walk up so many flights of stairs. Also, water pressure could only provide running water to about 15 meters. Development, steel, reinforced concrete, and water pumps have made possible construction of extremely tall buildings, some of which are over 300 meters tall. Other development essential to practical skyscraper development was invention of elevator. Considerable effort in developing improved design and construction procedures to address typical problems encountered in high-rise residential buildings. They found ways to upgrade parking garages, enhance envelope durability and improve multi-unit buildings thermal envelope. They found ways to upgrade parking garages, enhance envelope durability and improve a multi-unit building's thermal envelope. Heat, ventilation, air conditioning systems, accessibility and environmental performance. But one of most important achievement is enhancement of steel and reinforced concrete to cope with ever increasing demand for fast and lasting construction. So you can say development of buildings happened in this way. Ways to upgrade parking garages, enhance envelope durability and improve multi-unit buildings thermal envelope, heat, ventilation and air conditioning systems, accessibility and environmental performance. But most important point is achievement of enhancement of steel and reinforced concrete to cope with ever increasing demand for fast and lasting constructions. Perhaps no other building material was analyzed. Studied or studied. Perhaps no other building material was analyzed, studied, and modified as concrete. I think top material now. Requirement for higher performance concrete, which is more durable and stronger, required greater quality control and enhancement of bond between concrete constituents and materials, overcoming weakness of concrete in tension. All these require higher quality control and higher technology in manufacture of concrete. In many parts of Middle East, there are important factors such as hot weather, sulfates and chlorides, unskilled workforce, deleterious substances, funds and speed of construction that influence durability of structure and bridges to great extent. There is also requirement to educate industry and society to importance of and so there is also requirement to educate industry and society to importance of quality control and to realize that additional cost and effort spent on quality is a greater saving in long run. This brings out importance of assessment of concrete quality and homogeneity in site, which lead to increasing demand for in situ non-destructive testing methods. Such methods would close gap between long time cubes and cylinders as indicators of strength and quality and actual conditions of concrete in structural elements. UAE is, for example, witnesses an extensive urbanization development and billions of dollars are spent on reinforced concrete construction projects. Many reinforced concrete buildings exhibited some signs of distress early in their service life. Awareness of importance of concrete durability has risen in region. However, repair techniques are essentially those involving short-term control of situation and use of imported systems which are not fully tested. What is meant by durable structure is in practice very subjective and difficult to define precisely. Should refer to structure maintaining a satisfactory performance over a determined period of time without requiring unexpected high costs for maintenance. Therefore, term service life design has replaced term durability. Previously it was service life design has replaced term durability. Being a quantifiable and measurable quantity, in principle, two basically different design strategies to ensure a required service life can be followed. Avoid degradation threatening structure. Avoid degradation threatening structure due to type of aggressivity of environment. We have to avoid degradation threatening structure because of aggressive environment, and also select an optimal material composition. Select an optimal material composition and structural detailing to resist for a specified period of use degradation threatening of structure. This was expressed by Mr. Scaffo emphasized. There have been many advances in concrete technology indeed. There have been many advances in concrete technology during 2.5 decades or more, 3 decades let's say. Full advantage shall not be derived from these advances unless they can be shown to be appropriate to environment in which these are to be used or included, and application and use of basic concrete design and construction technique is sound. Good performance can only be achieved when designs allow for buildability, constructionability. Very important. I use all this time in my postings, constructability or buildability. So what it says that there is no meaning of these technologies advancements if we cannot do designs according to requirement. So full advantage shall not be derived from these advances unless there can be shown to be appropriate. It can be shown to be appropriate to environment in which these are to be used, and application as well as use of basic concrete design and relevant construction technique is sound. Good performance can only be achieved when designs allow for constructability or buildability. Ease of construction and if high standards of supervision as well as workmanship are used and of course imposed. Performance is also dependent on appropriate performance is also dependent on how to use appropriate technologies for specific environments, which may be both macro and micro. In past, there has been tendency for concrete technology developed by Europe and North America to be imported into other parts of the world with markedly different environments. Resulting poor performance has led to realization that existing technologies require to be checked out for their effectiveness in specific locations before use. Problem of concrete durability is hot weather being very complex. It can be seen that concrete structure in hot, arid environment tends to deteriorate more rapidly than those in temperate regions of world, unless particular precautions are taken. Increase in temperature also increases cracks, including plastic shrinkage, cracking, and drying shrinkage, cracking, facilitate ingress of salt-laden water and moisture, causing disintegration of concrete due to sulfates, attack, and corrosion. I repeat, it can be seen that concrete structure in hot. It can be seen that concrete structure in hot, arid environment tends to deteriorate more rapidly than those in temperate regions of world, unless particular precautions are resorted to. Increase in temperature, of course, increases cracks, including plastic shrinkage, cracking, and drying shrinkage, plastic shrinkage and drying shrinkage. Such cracks are increased, facilitate ingress of salt-laden water and moisture, causing disintegration of concrete due to sulfates, attack, and corrosion. Disintegration of concrete due to sulfates, attack, and corrosion. Carbonation, which reduces passive effect of concrete on reinforcement corrosion, proceeds at a faster rate at higher temperatures. Carbonation impacts at higher rate at high temperature. Even good concrete, where chlorides have been included at mixing stage or have entered from an external source, deteriorate more quickly than it would be in temperate climate. Even good concrete, where chlorides have been included at mixing stage or have entered from an external source, deteriorate more quickly than it would be in temperate climate. It has been reported that chemical agents, namely water reducers, retard carbonation, as these would promote densification of concrete. On the other hand, mineral admixtures such as fly ash, silica fume, and blast furnace slag have been reported to increase rate of carbonation. Since high strength concrete is characterized by a low porosity and a more uniform microstructure compared to that of normal strength concrete, this indicates a high resistance to penetration of carbon dioxide and chloride ions into concrete. However, during production of high strength concrete, both macro cracking due to plastics, shrinkage, and micro cracking due to self-desiccation, both macro cracking due to plastic shrinkage and micro cracking due to self-desiccation may represent potential problems from a corrosion protection point of view. Even for normal strength concrete, production of concrete with a good and stable air void system is normally a problem, but in presence of high doses of super plasticizer, establishment of a good and stable air void system is even a bigger problem. By increasing concrete strength from 50 to 100 MPa, by increasing concrete strength from 50 to 100 MPa, abrasion of concrete was reduced by roughly 50%. Increasing concrete strength from 50 up to 100 MPa, abrasion of concrete was reduced by roughly 50%. At 150 MPa, abrasion of concrete was reduced to same low level as that of high quality massive granite. Very often, it's not improved strength which is a primary objective, but rather overall improved performance. Therefore, term high performance concrete covers high strength concrete. I repeat, by increasing concrete strength from 50 to 100 MPa, abrasion of concrete was reduced by roughly 50%. At 150 MPa, abrasion of concrete was reduced to same low level as that of high massive granite. Very often it's not improved strength which is primary objective, but an overall improved performance. Therefore, high performance concrete covers high strength concrete. In many areas, large quantities of resources are being spent on maintenance and rehabilitation of concrete structures due to lack of durability. There exists a great challenge, therefore, for engineering profession to utilize and further develop technology of high strength concrete or high performance concrete for benefit of profession and society. Use of admixtures and additives in Gulf have gained greater interest and acceptance, leading to an extensive increase in amount of concrete which contains admixtures. Climatic conditions and requirement to stretch concrete to its ultimate capabilities make use of admixtures not only necessary but a must. However, engineers in region are finding themselves grappling with products, standards and specifications which emanate from other countries and working in climate conditions which admixtures have not been tested in. Assumptions that an admixture that retards to 21 degrees Celsius shall do so at 33 degrees Celsius is not valid. Assumption that an admixture that retards at 21 degrees Celsius shall do so at 30 degrees Celsius is not valid. Concrete mixtures incorporating fly ash. Concrete mixtures incorporating fly ash, silica fume or fine cements frequently have a low to negligible bleeding rate. You can say concrete mixtures incorporating SCMs, you can say supplementary cementing materials, frequently have a low to negligible bleeding rate, making such mixtures highly sensitive to surface drying and plastic shrinkage, even under moderately evaporative conditions. Certain admixtures increase time of initial setting or reduce amount of water required for a given initial slump or both. But such concretes may stiffen faster, sometimes too fast, even for a cement and an admixture that separately meet all specifications. So it says certain admixtures increase time of initial setting or reduce amount of water required for a given initial slump or both. But such concretes may stiffen faster, sometimes too fast, even for a cement and an admixture that separately meet all specifications. It's imperative that government institutes responsible for construction industry. It's imperative that government institutes responsible for such construction industry should join hands with universities to expand education and implementation of quality control. Cost of raw materials and manufacture of concrete is same for good and bad concrete. Cost of raw materials and manufacture of concrete, of course, is same for good and bad concrete. Difference of additional 5% cost of quality assurance or requirement could lead to a saving of more than 70% in life cycles of structures. We should never settle in Middle East of building. We should never settle in Middle East of building to list 30 years. We should never settle in middle to list 30 years, but must target for 70 years or more. Bridges should last more than 120 to 150 years. An important building should reach 200 to 250 years. That is what point is. It's not far-fetched at all. Now there are structures that are being designed for 250 and 500 years. British Library is designed for 1000 years and a temple in China is designed for 5000 years. I repeat, very important paragraph, though may be referred to. It's not by original writing. Of course, it is reference, but it should be very clear and known. It's imperative that government institutes responsible for construction industry should join hands with academical institutes so that education is disseminated and implementation of quality control is effective. We know materials are equally costly. Cost of raw materials and respective manufacturing of concrete is same for both types of concrete, whether it is good or bad. Whether it is good or it's bad, cost is same. Difference on additional 5% cost of quality requirement or assurance could lead to a saving of more than 70% in life cycle of structure, and that is more important. We should never settle in middle of 30 years. This is our building, as we usually say in Middle East, 30 years maximum, though there's warranty of 10 years only. But life may be 30 years, but we are not that much affording. So we can increase life cycle of that. Because if life cycle of structure is increased, we can get advantage of finishing items and others as well. So it's much more important that we have to keep in view all this. We should never settle for 30 years. We should think for 100 years, 70 years, 80 years, 90 years, 100 years, 200 years, 300 like that. It's not for fetched at all. This criteria is not met at all. There are examples that in, you can say, British designed, certain structures are designed all over the world somewhere as references given to 50 and 500 years. It says British Library is designed for 1000 years and Temple in China is 5000 years. These are only references. I don't have any evidence for this, but this is reference. Now there are ways in which concrete construction techniques can be considered durable and environmentally considerate are, here is, you can say, self-compacting concrete, which requires no vibration for compaction and so reduces noise on site, increases construction efficiency and minimizes workforce. Robot formwork can be designed to maximize reuse and minimize waste. Chemicals, you can see these include biodegradable vegetable oil-based release agents, and of course admixtures. For example, many admixtures used in United Kingdom to improve performance are derived from natural products such as lignin, a byproduct of paper industry. Specialist techniques such as pre-stressing are more common every day. We are finding that these make it possible to use less material and to create longer spans. These lead to enhanced flexibility of buildings in use. Use of stainless steel not only enhance our construction, but it plays an important role in having a more durable and sustainable structures. Here is now a case study we are referring to, and this is of course a reference. I have no contribution on this. It says, effect of hot weather concreting on cracking tendency of tensile specimen. This is about a part discussion on durability of concrete in Arabian Gulf. This case study, hot weather introduces many problems. Hot weather introduces many problems in producing, transporting, casting and curing concrete. Hot weather introduces many problems, and these are produced in how to transport, how to cast and how to cure concrete. And this can adversely affect properties of fresh and hardened concrete. These issues, that is transporting, casting and curing, can affect properties of fresh and hardened concrete. Hot weather decreases workability of fresh concrete mix. We know that it accelerates rate of stiffening, that is slump loss, and reduces setting time. Moreover, it aggravates cracking due to plastic shrinkage and due to drying shrinkage. Whole para says, very small para, hot weather introduces many problems in producing, transporting, casting and curing concrete, which can adversely affect properties of fresh and hardened concrete. Hot weather decreases the workability of fresh concrete mix. It accelerates rate of stiffening or slump loss and reduces setting time. Moreover, it aggravates cracking due to plastic shrinkage and due to drying shrinkage. In some parts of region, when casting in hot days, water is added to fresh mix to enhance its workability and to retard its setting. This kind of conduct can, after a short time from finishing, cause a reinforced concrete member in upper reinforcing bars to be imprinted on its surface and produce long lines of splitting cracks. These plastic cracks may impair bond strength of these upper bars with concrete. It's a good example of practical aspect. What it says, in some parts of region, when casting in hot weather conditions, water is added for convenience, which is wrong actually. Water is added to fresh mix to enhance its workability and to retard its setting. This kind of conduct can, after a short time from finishing, cause a reinforced concrete member in upper reinforcing bars to be imprinted on its surface. You can see some steel imprints are seen on surface of concrete, and this produces long lines of splitting cracks, which plastic cracks may impair bond strength of those upper steel bars with concrete. Effect of casting under hot weather conditions on crack width and crack spacing of tensile specimen were investigated. Concentric and eccentric tensile specimen were utilized, and end slip and crack spacing were measured during tests. Tests were performed on 5 concrete mixes. Tests were performed on 5 concrete mixes. Tests were performed on 5 concrete mixes with water cement ratio varying between 0.45 to 0.6, simulating moderate and high temperature conditions. Tests were performed at ambient temperatures, that is 20 degrees, 40 degrees and 50 degrees Celsius, and relative humidities of either 25 or 50%. These observations draw attention to the fact that there is a great interference between practice of casting in hot weather with bond strength of concrete and tendency to crack. So I was saying conditions were that water cement ratio was between 0.45 to 0.6 and ambient temperatures 20, 40 and 50 degrees Celsius, relative humidity is 25 or 50%. So in these observations draw attention to the fact that there's a great interference between practice of casting in hot weather with bond strength of concrete and practice of casting in hot weather with bond strength of concrete and tendency to crack. Cracking before applying load affects state of stress after applying loads in cracks orientation. The scope of this research work is to investigate effect of hot weather concreting on crack width and crack spacing of tensile specimen. 2 types of tensile specimen, concentric and eccentric, were utilized and slip and crack spacing were measured. So here is that. Tests were conducted on 76 into 76 into 395 mm prism that you can see in this sketch. This is 3995 height, and here is this 76 by 76, It should be here, 76 is here by 76 square, and height is this, a cylindrical 1, and what it stays, here is 76 by 76, and here is 12 mm dia steel bar here, you can see here, and point of measuring end slip, this is one point, this other point, this one, and here is that, here is 17, here is 17 from 17 mm from ends, and you can say then 15 mm and 15 mm, and bar is 12 itself. So 12 is bar, 15 slip, 15 and 17, and 15 is 17, point of measuring end slip. And here is cross section, and this is your plan, here is plan, and here is steel bar here, you can say 12 mm dia steel bar here, and this are the points of measuring end slip, cross section A, and this is points of measuring end slip here. So now what it says that we have to see, here is 10 mm, here is 12 mm, here is 54 mm, and this is 76 by 76 mm. It says this test was conducted in prismatic uniaxial reinforced concrete. Prismatic uniaxial reinforced concrete specimen with a steel bar of 12 mm diameter embedded in concrete. Steel bar is protruded 250 mm from both ends. So this is steel bar, 12 mm dia, that's shown by dotted lines in this prism. This steel bar is protruded 250 mm from both ends, and that is what it is, 250 mm from both ends here. This is that, you can say, from both ends. The following types of tensile specimens were tested. 1. Concentric tensile specimen, concentric TC, that is concentric tensile specimen, each reinforced with a concentric steel bar as shown in figure 1A, and that is figure 2, here is figure 1A is shown, here 1A, 4 TC specimen were cast for each series. Now eccentric tensile specimen TE, each reinforced with an eccentric steel bar is shown in figure 1B. 2 TE specimen were cast for each series. Now in addition 300 by 100 by 100 mm concrete cubes were cast from each series to determine compressive strength. Test results showed that hot weather concreting increased width of cracks in tensile specimen about 20 to 40% for mixes with low water cement ratio and low slump. On the other hand, crack widths decreased in range of 30 to 40% for mixes with high water cement ratio and high slump. No tangible effect on crack spacing was noticed. Test results showed that hot weather concreting increased width of cracks in tensile specimen about 20 to 40% for mixes with low water cement ratio and low slump. On the other hand, crack widths decreased in range of 30 to 40% for mixes when high water cement ratio and high slump. No tangible effect on crack spacing was noticed. Only width is affected, width of crack is affected. Low slump and you can say low water cement ratio increased width of cracks, while high slump and high water ratio reduced width of cracks. You can see this here. It's shown as we say this is prismatic. So these were seen, and we can say if you can see this here, and if you go further we'll see what it says now, non-destructive testing for concrete compressive strength. Non-destructive testing for compressive strength. Non-destructive testing is a useful and practical approach to determine in situ compressive strength of concrete. It's used a measure for quality as well as to determine uniformity of materials in existing structures. In practical applications, non-destructive testing can be utilized to calculate relative compressive strength and to provide guidelines for continuing construction in an effective and safe manner. Utilization of NDT, non-destructive testing, can help in determining uniformity of strength in an existing slab, deck, and many may also utilized to determine in situ strength, which may result in fewer cores required when determining strength of an existing slab. It's very important knowledge area. If you know, but those who do not know, I repeat. NDTV means non-destructive testing, a useful and practical approach to determine in situ compressive strength of concrete. And it's used to measure quality as well as to determine uniformity of materials, not heterogeneity, uniformity of material in existing structures. In practical applications, non-destructive testing can be utilized to calculate relative compressive strength, relative not original, relative compressive strength, and to provide guidelines for continuing construction in an effective and safe manner. NDT can help in determining uniformity of strength in an existing slab, deck, and may also be utilized to determine in situ strength, which may result in fewer cores required when determining strength of an existing slab. So cube and cores testing, of course, it is which can help to know. You have to know about strength of concrete, relative strength of concrete. Some non-destructive tests, we can say, that are used to determine strength of concrete at early age are maturity concept, pull-out, and ultrasonic test. Use of more than one testing method can be beneficial in attaining higher quality control standards. In this task, Windsor pin test, ASTM C803M, Windsor pin test, skimmed rebound hammer test, ASTM C805 were evaluated. In order to meet scope of proposed task 5 concrete mixes, with variation with various mix composition were investigated. Tests were conducted at various ages of 1, 3, 7 and 28 days. First day, third day, 1 day, 3 days, 7 days and 28 days. Means 1 and 7 and 20 are common, but 1 and 3 were added. Mixes were designed to have strength variation between 10 to 80 MPa, 100 mm cube and 150 into 300 mm cylinders were utilized. Tests were performed on 5 concrete mixes using type 1 Portland cement, normal cement mix, not by part 1. Mixes 1 was used as reference. Mix 2 to 5 contained a combination of microsilica, metakaolin combination microsilica, metakaoline and ground granulated blast furnace slag GGBS. Mixes contained coarse aggregate with maximum nominal size of 20 mm. Mixes contain coarse aggregate and maximum nominal size 20 mm. Rio build and galunium admixtures. Rio build and galunium admixtures were utilized in mixes. These are admixtures, Rio build and galunium. Galunium high water reducing admixture was utilized in mix 5 that is expected to produce concrete with compressive strength 80 MPa, and that is galunium. Water cement material ratio for 5 mixes was varied between 0.32 to 0.38. Tests were carried out on 5 concrete mixes. Mix 1 to 5. A total of 60 concrete cylinders. A total of 60 concrete cylinders. 150 into 300 mm and 120 cubes 100 by 100 by 100 mm were cast utilizing ready mix batching. Half cylinders and cubes were left to cure inside with temperature variation between 31 to 43 degrees Celsius. 50% of cylinders and cubes were left to cure inside with temperature variation between 31 to 43 degrees Celsius, while other half were wet cured in laboratory according to ASTM C39 specifications. A total of 5 concrete retaining walls were also constructed on site. Non-destructive tests were performed on concrete walls as well as cylinders and cubes. 3 cylinders and 3 cubes cured under laboratory were tested at different ages of 1 day, 3 day, 7 day and 28 days, and similar number of cylinders and cubes were tested at field conditions. Tests were performed utilizing Windsor pin and Schmitz rebound hammer. Windsor pin and Schmitz rebound hammer non-destructive tests. 10 readings were taken on each cylinder with each device. 10 readings were taken on each cylinder with each device. Cylinders and cubes were then capped and tested for their compressive strength. Following conclusions can be made from testing cubes, cylinders and walls under laboratory and field conditions. Let's see. It says compressive strength 1 day of cube and cylinders, 1 day of cubes and cylinders cured at site condition have higher strength than specimens cured at lab conditions. Opposite trend was obtained at 28 days. What is the conclusion is? Compressive strength at first day of cubes and cylinders cured at site condition have higher strength than specimens cured at lab conditions. Opposite trend was obtained at 28 days. Overall ratio between cube and cylinder strength for laboratory and field conditions averaged 1.16. Cube and cylinder strength for laboratory and field condition averaged 1.16. Linear and exponential relationship. Linear and exponential relationships between compressive strength and pin penetration as well as compressive strength and rebound number were established under laboratory and field curing conditions. Graph in this study provided a good linear relationship. Graph in this study provided a good linear relationship between compressive strength and pin penetration as well as compressive strength and rebound number. Coefficient of variation was small, indicating that both methods are reliable for wide range of compressive strength between 10 to 80 MPa. And cubes, various buildings, and there is just testing it done here. You can see now temperature effect on repair deficient reinforced concrete beams using fiber reinforced polymer materials. I think it's missing here. This page is not available, so no problem. We'll go back. We have to think of this now. It says compressive strength on first day testing, and it's say first day testing of cubes and cylinders that are kept on site is higher than those in laboratory, and it's opposite on 28 days. And there's a ratio which says about cubes and cylinder strength. Overall ratio between cube and cylinder strength for laboratory and field condition is 1.16, means laboratory gives 16% more overall ratio between cube and cylinder strength. Overall ratio between cube and cylinder strength for laboratory and field condition is 1.16. Cube and cylinder means cube is 16% more than cylinder. Overall ratio between cube and cylinder strength for laboratory and field condition is 1.16. Linear and exponential relationship between compressive strength and pin penetration as well as compressive strength and rebound number were established under laboratory and field curing conditions. Graphs provided a good linear relationship between compressive strengths and pin penetrations as well as compressive strength and rebound number. Coefficient of variation being small, indicating that both methods are reliable for whole range of compressive strength between 10 and 80 MPa. That is relation between compressive strength and pin penetration as well as compressive strength and rebound hammer. Coefficient of variation was small, indicating both methods are reliable for wide range of compressive strength varying between 10 and 80 MPa. So what was this? It's important what it did actually. You have to re-understand. It says tests were carried out on 5 concrete mixes. 5 concrete mixes, that's 1 to 5. Total of 60 concrete cylinders. 150 300 mm means 150 dia, 300 mm height, and 120 cubes, 100 by 100 by 100. Cast utilizing ready mix, half cylinders and cubes were left to cure in site with temperature variation between 31 to 43 degrees Celsius, while other half were wet cured in laboratory conditions, laboratory specifications. Total 5 concrete retaining walls were also constructed on site. Non-destructive tests were performed on concrete walls as well as cylinders and cubes. 3 cylinders and 3 cubes cured under laboratory were tested at different ages of 1, 3, 7 and 28 days. And similar number of cylinders and cubes were tested at field conditions. Tests were performed utilizing Windsor spin and Schmidt's hammer, non-destructive tests, and readings were taken, etc., etc. Here also just for information, I have brought this paper for discussion because we have to understand a lot in this, and without understanding we cannot grasp anything. I think purpose of this paper has been over, and again I would say what is important is for sustainability, that makes very important issue here, sustainability of concrete, how to hold it, how to use it. It says reduction of emissions. How can we develop sustainability? And that is only a way: reduction of emissions, more efficient use of resources, and reuse of waste, increased consideration for people's safety and health. And of course we can cover all these within quality issue. Quality issue is not limited, it is expanded, it's applicable to every act on properties, on performance, and whatever we can say. Environment issues are these, as we said: issue of emission, resources best use or more effective efficient use, and reuse of waste, and safety and health. These are environmental related, and we have many others likewise. Of this, as it says that as for example here sustainability is defined, or we know that, but yet what I want to say this is sustainability, we should say like this: sustainability can be defined as process of designing structures such that respective use or their use or these materials use energy and resources at a rate that does not compromise and harm natural environment or reduces natural resources. Sustainable structures are designed to save natural resources, to minimize waste, to minimize embodied energy in structure, and to have a long life with minimal maintenance. And of course, durability definition. Durability is defined as, you can say, kind of property in concrete, or you can say resistance of concrete To what? If concrete can resist weathering conditions, chemical attacks, and other degradation processes. What is weathering resistance, chemical attacks resistance, and other degradation processes? And also it's defined as design of structure to meet design life requirements. Design of structures to meet design life requirement. And design life of project is defined period of time at which a structure is required to perform. Period of time at which structure is required to perform safely after date of practical completion. With an acceptable probability that operate within its specified design parameters without replacement, refurbishment or major maintenance during that time. When performance of structure and its appearance are acceptable, as long as users require structure, for structure is considered durable. So we can say durability limits to or goes to what level of resistance our concrete has. This resistance to weathering conditions, resistance to chemical attacks, and other degradation process. These are practical ones. How strong concrete is in weathering conditions, which are bad weather conditions, we can say, hot weather, cold weather, chemical contents, chemical attacks, and whatever other degradation processes, and how design has been affected, keeping abreast all these attacks. And it affects design life of project, and there should be no major maintenance on that if it is really durable. So we can say how concrete performs. It's more important. How does it perform? It is more important than something else. And there are some, we can say, also, let us say chloride corrosion. It's also very important part. Chloride, rapid chlorides, we call them. Chloride corrosion, rapid chloride penetration, columns, how many columns actually enters. That's what we talk many times. Chloride penetration, chloride corrosion, rapid chloride penetration is called. And of course in Arabian Gulf, it's major form of deterioration way of concrete. Concrete deteriorates because of chloride induced reinforcement corrosion. Corrosion and expansion of rebar. Corrosion and expansion of rebar embedded in concrete causes severe damages to reinforced concrete structures. Concrete is not directly affected by chloride ions. Chloride ions in concrete comes from two main sources, which are penetrated chlorides from surface environment and cast-in chlorides contributed by mixed constituents. So one entry of chloride is from two sources. One is penetrated chlorides from surface environment and cast-in chlorides contributed by mixed constituents. Chlorides affect in either acid soluble or water soluble, from which most damaging form as they freely become free to attack surrounding reinforcing steel. Picking used concrete mix should be done carefully if not constituents. Chlorides can be found in reinforced concrete before the structure goes in service. Reinforcement corrosion in substructures is mostly substructures, medicines, say foundations, is mostly due to chlorides diffusion from soil and groundwater. Chloride diffusion from soil and groundwater, while in superstructure, corrosion in most cases is affected due to chloride ions contributed by mixed constituents as well as from weather or gases. An important factor that help in accelerating concrete deterioration due to chloride induced reinforcement corrosion is presence of sulfate and chlorides ion in soil and groundwater. Corrosion rate increases in presence of chloride. Corrosion rate increases in presence of chloride in association with sulfate concentration. Sulfate concentration and presence of chloride, which is challenge for underground structures where sulfate and chlorides salts are present. And for superstructure, effect of high temperature exacerbates problem of chloride induced corrosion. Common practice is done to minimize chloride and sulfates, which is washing aggregates. There are often the other factors that affect chloride induced reinforcement corrosion, which are quality of concrete and concrete cover. Poor quality often leads to reinforcement corrosion, even if chloride contamination is in acceptable limit. Other factor, and the factor that aggravate chloride penetration, is cracks and construction joints, as they allow chemical and such as de-icing salt, chemicals such as de-icing salts to enter concrete and access embedded reinforced steel. Environmental cracks there are, you know that concrete structures cracking at early stages mostly due to durability. Early age cracking is due to using high early strength concrete mixes to support high speed of modern construction trends. These cracks form from allowing moisture and oxygen to steel surface. What else we can extract from this for revision? And here is carbonation of concrete. Carbonation of concrete is reaction between product of cement hydration. Carbonation of concrete is reaction, reaction between product of cement hydration and acidic gases in atmosphere. Acidic gases in atmosphere and hydraulic cement, you can say reaction. Carbonation of concrete is reaction between products of cement hydration and acidic gases. Carbonation of concrete is reaction between products of cement hydration and acidic gases in atmosphere. Problem of concrete carbonation arises in industrial atmosphere, where concentration of carbon dioxide is usually higher than normal acidic gas concentration, which is only 0.03%. Alkalinity is reduced. Alkalinity is reduced to a pH value of 10 due to carbonation, and which alkalinity is reduced to pH value 10 due to carbonation, which results in losing reinforcement protection from concrete and leads to reinforcement corrosion. Embedded corrosion steel expands, causing a severe damage to reinforced concrete structure. Embedded corroded steel expands causes a severe damage to reinforced concrete structure. Its carbonation process very slow. A good quality concrete reduces damage. Moreover, carbonation does not occur when concrete is constantly underwater. It's not uncommon to see carbonation of concrete to reinforcement steel, as humid hot weather of Arabian Gulf is conducive for carbonation of cement. Sulfate attacks. To give me some time. Sulfate attack, let me finish this and I'll take time then. Okay. A chemical background. Sulfate, I'm talking sulfates. We use sulfate resisting cements long back. A chemical breakdown mechanism which is a form of concrete deterioration, chemical breakdown. Chemical breakdown mechanism which is form of form of concrete deterioration where sulfate ions attack component of cement paste. Sulfate ions attack components of cement paste. Sodium, then calcium, potassium and magnesium. Keep in mind SCPM, sodium, calcium, potassium and magnesium. Sodium, calcium, potassium, magnesium. Sulfates are most common types of sulfates, you can say, due to their chemical reaction, such as reaction with hydrated lime, reaction with hydrated calcium aluminates, and reaction with cement paste, which all produce solid products with larger volumes than input product. All sulfates are harmful. Main factors affecting rate and severity of sulfate attacks are C3A. Permeability of concrete, CaOH2 content and concentration of sulfate in waterborne solutions. Main factors affecting rate and severity of sulfate attack, C3A, content and permeability of concrete, CaOH2 content and concentration of sulfates in waterborne solution. Heavy crust of salt. Heavy crust of salt is left in topmost soil of coastal areas. Heavy crust of salt. Crust of salt is left in topsoil of coastal areas. Since subka areas, heavy crust of salt is left in topsoil coastal areas of the Gulf. Gulf is called subka due to frequent flooding and to capillary rise mechanism, which are followed by intense evaporation. This capillary rise mechanism, which is followed by intense evaporation, concrete structures are subject to sulfate attack, deterioration when these are exposed to sulfate solutions. Placed in sulfate bearing soils, groundwaters, reducing alumina content by limiting C3A in Portland cement is considered one of most common ways of protecting concrete against come back. I'll think. Let me see. I'll be give. I think that already it's not taking care 00. I think it's. Let us see how it works. If it works fine, we'll continue. If it doesn't work, okay, fine. This rubbing Gulf and see. I'll go for 5 minutes and come back. Otherwise, it's a problem for me. If you can wait, fine. It's going to be long hours. And let me come back a minute, 5 minutes to see. There's no rain now. And if it's rain, let me see. See. I'll also put off my battery now. this privilege now? Why not? We have that one. You have that one, no problem. So, we discussed this around, and I think this works well till now. It is still working, I think so. 3 minutes, okay, no problem. Let's continue as much as possible. It says, Arabian Gulf region does not have a uniform environment. It says, it is here you can see in this continental area, in this island. This is non-coastal area, and it is called arid, hot and dry arid, with less humidity, and this is hot and humid in coastal area. So what it says, hot and dry, that's figure 1, and hot, humid zones of Arabian Peninsula. And it's called hot and dry, that's arid, and hot and humid, that's coastal area. This is generally Arabian Gulf region does not have a uniform environment, as climate and environment of countries vary significantly from one region to other. So one country cannot generalize climate characteristics for all area. Clearly apparent differences in temperature, humidity, rain, temperature, humidity, rain, wind, geology of soil and raw materials in Arabian Gulf region. Region can be differentiated by 2 climatic zones. One is dry, that is inland or non-coastal areas, which we call hot, humid, that is coastal. Moisture or humidity is more, that is hot, humid, and one is dry, that's inland. So inland is dry and coastal is hot, humid. Temperature will vary by as much as 30 degrees Celsius and relative humidity 40 to 95% during a typical summer day. Minimum to maximum temperature range is from 3 to 50 degrees Celsius, and relative humidity may be as high as 95% or as low as 5%. Combination of these values result in exposure conditions that being very detrimental to concrete materials, members and structures. These exposures cause damage due to thermal and mechanical stresses. Main challenges that faces reinforced concrete construction in Gulf region are hot, humid, hot, dry and salty environments. In warm climate, high ambient temperature affects concrete structures, as heat is a driving energy source that accelerates deterioration mechanism progresses. And that is heat is a driving energy to deteriorate mechanism. It says it can accelerate progress of deterioration. In warm climate, high ambient temperature affects concrete structures, as heat is a driving energy source that accelerates deterioration mechanism progress. Classical law connecting heat and rate of chemical reaction states that for each increase of 10 degrees Celsius in temperature, rate of chemical reaction is doubled. Many researches on corrosion problem have been published in Arabian Gulf. These researches show that most problems in existing structures were due to low quality materials and severe environmental conditions combined with poor design and construction practices. And due to poor mix design and lack of quality control in field. Moreover, for concrete durability in Gulf, weather is worst in world. Weather is worst in world. For that reason, it is challenging to see structures survive their intended service life. It's very important paragraph. I repeat, many researches on corrosion problem have been published in Arabian Gulf. Researches show that most problems in existing structures have been due to low quality materials and severe environmental conditions combined with poor design and construction practices. And due to poor mix design and a lack of quality control in field, moreover, conventional water resources of Arabian Gulf region include surface water, groundwater, and shallow and deep aquifers. Non-conventional water resources come from desalination and wastewater cycling, while water resources are in short supply. Demand for water is growing in GCC countries. Given the situation, question of optional management or organization of water resources is clearly of crucial importance, with implications not only for future development of these countries but also for sustainability of their past economic and social achievements. Dilemma arises from continuing growth in demand, which is a result of population increase and other social factors in conjunction with the fact that region is already exploiting all causes of increasing water demand include population growth and rapid urbanization. Besides wasteful consumption pattern both in domestic and agricultural sectors, all countries in the region have a high level of urbanization, more than 84% in most cases. Water consumption in these countries range between 300 to 750 liters per person per day, which ranks among highest in world. In fact, importing water from various Arabian Gulf regions. However, this option poses many economic and technical difficulties. Alternative options include importing water from Nile, Iran, Pakistan, Turkey, but all of these have problems.